Good, so the homework this week was factor and remainder theorem stuff. And question 1, find the quotient and remainder when x squared plus x plus 1 is divided by x minus 1. Now, last year, we may have done this by the old traditional long division method, but we've got a new alternative. Did anybody do it with the new alternative?
Half.
Some people used half, did it?
Yeah.
I'm not sure. No, more than one, quite a few people. So, our new method of thinking about this says, what we're going to do is we're going to take x... Oh, I haven't aligned the board. Right, we'll be done really quick. Sorry, video world. It's been a while since I've uploaded one. We're back to the old general incompetence style. Right, so what we're saying is x squared plus x plus 1. If we're dividing it by x minus 1, it's going to be x minus 1 times something in that bracket, and we're expecting a remainder, because it said find the quotient and remainder, so we're expecting to have a number over here. So we think this through logically. What would go in the first place? Well, to get... Well, it's not much, is it? It's only x squared plus x plus 1. That's really dull, isn't it? Anyway, we're expecting an x to give us the x squared. So we're going to put x there. What a disappointing question. We need an x in the middle. Now at the moment we've got minus 1 of them. So this bit here must make it up to being plus 1. So to get from minus 1 to plus 1, this would need to be a plus 2 to give us the extra 2x. And if we sort out the numbers, we're expecting to have, we need to have a plus 1 ultimately. At the moment we've got a minus 2. So to resolve that, to get from minus 2 to the plus 1, we need to add 3. And you may have done that long division, you would have got the same answer. So because it did say find the quotient and remainder, we're going to say our quotient is x plus 2, and our remainder is 3. Joe?
If you didn't state it, quotient is la-di-da-di-da, remainder is la-di-da-di-da, do you get full marks or not? I assume not.
Yeah, I think if it was fairly obvious that that's what you meant.
No, that's good.
You don't need the la-di-da-di-da mix.
Yeah.
But right. Everybody happy?
Yes. Yes.
I did think about that.
Question 2. The cubic polynomial f of x is given by f of x equals 2x cubed plus ax squared plus bx plus 15. Remember, we did an example similar to this on Friday, where a and b are constants. It's given that x plus 3 is a factor. This is all about interpreting the question, isn't it? So the bit in yellow here, x plus 3 is a factor of f of x. What does that tell us about what's going on? How do we turn that into a mathematical equation? Go on, David.
Well, f of minus 3 equals 0.
That would be perfect. F of minus 3 must be equal to 0. The other bit, which I'm about to shade in green, I'm doing it now, there it is, which says that if we divide by x minus 2, the remainder is 35. So what does that tell us as a little follow-up statement? Go on, James.
F equals 35.
F of 2, yeah, equals 35. So we get these two statements from it. So that is going to allow us to find the values of a and b. So let's work it through. So f of minus 3 being 0, that gives us 2 times minus 3 cubed plus a times minus 3 squared plus b times minus 3 plus 15 is 0. You can of course use a calculator at this stage. Minus 3 cubed is negative 27, doubled is minus 54. That would be plus 9a, minus 3b, plus 15, so 0. So I think I'm going to write this as being 9a minus 3b is 15. No, it's not. It is something else. 39.
No, but that's right.
That it would be equal to 30. And I think let's divide that by 3, because 3 goes into everything there. So 3a minus b is 13. Call that equation 1. Let's look at the f of 2 is 35. 2 lots of 2 cubed plus a times 2 squared plus b times 2 plus 15 is 0. So that gives us 16 plus 4a. Oh, it's 35, not 0, yeah, thanks. It's 35, isn't it? Because the remainder is 35.
I'll make that mistake.
Plus 2b, or not.
Grim.
That's 2b or not 2b, you see. It was
We got
Yeah.
giving us 4a plus 2b is 4. Which again has a common factor of 2. 2a plus b is 2. We've got equation 2. Look at these. We need to find a and b. Fairly straightforward simultaneous equations. Dave thinks he's going to add them together. And in fact he is. If we add them together, we get 5a, the b's would cancel out, that's 15. A is 3. If we go back and work out what that means b is, that means that 6 plus 3b, sorry, 6 plus b is 2, so b is negative 4. Could we get that? A is 3, b is minus 4. Do we find ourselves in general agreement? Good. It then said, using these values of a and b, divide f of x by x plus 3. What do we know about x plus 3? It's a factor. Okay, so it's not really asking us for long division, it's asking us to factorise with this. Now, we've got, what is it, 2x cubed plus 3x squared minus 4x plus 15. And we're supposed to divide by x plus 3. And again, why do long division if you don't need to? And so if we're thinking of this now, to get the 2x cubed, we need to think, what do we multiply the x by? 2x squared. Somebody whispered it, or maybe it was just in my head. Let's keep this as simple as we can. We know that x plus 3 is a factor, because the question told us that. So the term at the end must be 3 times something to give us 15. Must be 5. All we're left with is the term in the middle. We've got 3x squared that we're after. Currently we've got 6x squared. So we need to take away 3 to get back to 3x squared. So x times this, that must be a minus 3x, mustn't it? Let's check the minus 4x term. That would give us 5x minus 9x, which is minus 4x. So it works. What did it say? Divide f of x by x plus 3. Okay, so we've done it. Does it it doesn't factor any further anyway, does it? 10 would have to be... Oh, it does. Does it? No, it doesn't. No. Right. Hurrah! And that's maths. We stop it now, Jesse.